Section 225.31 General states that every service, feeder, and branch circuit shall be provided with a readily accessible means of disconnecting. Section 225.32 Service disconnects requires a single service disconnect for each service. Exception number 1 states that a service disconnect shall not be required where the disconnect is part of a meter socket assembly or equipment. Section 225.33 Feeder disconnects requires a disconnect for each feeder. Exception number 2 states that a disconnect shall not be required for each feeder where all or part of the feeder conductors are protected by a single overcurrent device at both ends of the feeder. Section 225.34 Branch circuit disconnects states that each branch circuit shall be provided with a readily accessible means of disconnecting. Exception number 2 states that a disconnect shall not be required for a branch circuit where the branch circuit overcurrent device is accessible. Based on these sections, a subpanel with up to 6 breakers can serve as the disconnecting means for a feeder if all of the following conditions are met. Firstly, the subpanel is supplied by a single overcurrent device. Secondly, the feeder conductors are protected at both ends of the feeder. Thirdly, the subpanel breakers are accessible. This interpretation is consistent with the language of the code and the intent of the code, which is to ensure that all circuits have a readily accessible means of disconnecting. It's vital to understand the implications of these rules for electrical installations, particularly in scenarios involving separate structures and subpanels. When dealing with a service panel located on a pole supplying a feeder to a subpanel in a separate structure, the question of whether a main disconnect is required in the subpanel often arises. The general rule is that every feeder must have a disconnecting means that is readily accessible to the user. This means that there must be a way to quickly and easily shut off the power to the feeder at the subpanel location. The primary disconnecting means is often a single main breaker, but the code also allows for up to 6 breakers to serve as the disconnecting means under specific conditions. The 6-breaker rule is detailed in the National Electrical Code, which permits up to 6 switches or circuit breakers to serve as the disconnecting means for service or feeder. The intent is to allow for simple installations to avoid the cost of a main breaker, while still providing a safe and effective means of disconnecting power. However, this exception comes with caveats. Each of the 6 breakers must be grouped in the panel and be readily accessible. The cumulative ampacity of these 6 breakers must be sufficient to handle the load served by the subpanel. It's also crucial to verify that the installation complies with local amendments and interpretations of the electrical code, as some jurisdictions may have stricter requirements. In the specific case of a subpanel fed from a service panel on a pole, several factors influence whether a main disconnect is required. If the subpanel is supplied by a single feeder protected by a single overcurrent device at the service panel, and if all the circuit breakers in the subpanel are readily accessible, up to 6 breakers can serve as the disconnecting means. However, if the subpanel is fed by multiple feeders, or if any of the breakers are not readily accessible, a main disconnect is required. The overcurrent protection at both ends of the feeder is another critical consideration. The feeder conductors must be protected against overcurrent at both the supply end, typically at the service panel, and at the load end within the subpanel. This dual protection ensures that any fault condition is quickly interrupted, minimizing the risk of fire or electrical shock. In installations where the feeder conductors are not protected at both ends by a single overcurrent device, a main disconnect is mandatory to provide a readily accessible means of de-energizing the entire subpanel. Accessibility is a key theme in electrical safety. The disconnecting means, whether a main breaker or up to 6 individual breakers, must be easily accessible to anyone who might need to shut off power to the subpanel. This means that the breakers cannot be obstructed by furniture, equipment, or other items that would impede quick access. The location of the subpanel itself must also be readily accessible, free from obstructions and hazards. Local electrical codes and regulations may provide further guidance on what constitutes readily accessible. The phrase readily accessible is not just a matter of physical access. It also implies that the disconnecting means should be clearly labeled and identifiable. Each breaker or switch should be marked to indicate what circuit it controls, making it easy to shut off power to specific areas or equipment. Clear labeling is essential for both routine maintenance and emergency situations, helping to prevent accidental shutdowns and ensuring that the correct circuits are de-energized. Before making any final decisions, it is crucial to consult with the local authority having jurisdiction AHJ. The AHJ is responsible for interpreting and enforcing the electrical code within their jurisdiction, and they may have specific requirements or interpretations that differ from the national code. Checking with the AHJ can help ensure that the installation complies with all applicable regulations and avoids costly rework or penalties. Consider that electrical codes are not static documents. They are regularly updated to reflect changes in technology and best practices. Staying current with the latest edition of the electrical code is essential for ensuring electrical installations are safe and compliant. Electrical contractors and installers should invest in continuing education and training to stay up to date on the latest code changes and interpretations. Regular inspections and maintenance are also crucial for ensuring electrical systems continue to operate safely and reliably. Over time, electrical components can degrade or become damaged, increasing the risk of fire or electrical shock. Periodic inspections can identify potential problems before they become serious, allowing for timely repairs and replacements. Maintenance tasks such as tightening connections, cleaning components, and testing safety devices can also help extend the lifespan of electrical equipment and prevent costly downtime. Furthermore, it is important to recognize that electrical work is inherently dangerous and should only be performed by qualified and licensed professionals. Working with electricity requires specialized knowledge, skills, and equipment to avoid injury or property damage. Attempting to perform electrical work without the necessary training and experience can be hazardous and may violate local regulations. Always hire a licensed electrician for any electrical work and ensure that they are properly insured and bonded. When planning an electrical installation, it is essential to consider the load requirements of the subpanel. The total ampacity of the circuit breakers in the subpanel must be sufficient to handle the expected load, with some margin for future expansion. Overloading circuits can cause overheating, damage to equipment, and even fires. Careful load calculations and proper circuit sizing are critical for ensuring electrical safety and reliability. In addition to load calculations, it is also important to consider voltage drop. Voltage drop occurs when the voltage at the load end of a circuit is lower than the voltage at the source end due to resistance in the conductors. Excessive voltage drop can cause equipment to malfunction, reduce efficiency, and shorten the lifespan of electrical components. To minimize voltage drop, use appropriately sized conductors and keep circuit lengths as short as possible. The NEC provides guidelines for calculating voltage drop and selecting conductor sizes to meet specific requirements. Grounding is another critical aspect of electrical safety. Grounding provides a low-resistance path for fault current to flow back to the source, allowing the overcurrent protective device to trip and to energize the circuit. Proper grounding helps prevent electrical shock and minimizes the risk of equipment damage. All electrical equipment and enclosures must be properly grounded in accordance with the NEC and local regulations. Ground fault circuit interrupters GFCIs are another important safety device that can help prevent electrical shock. GFCIs monitor the current flowing in the hot and neutral conductors of a circuit and trip the circuit if they detect an imbalance, indicating that current is leaking to ground. GFCIs are required in certain locations, such as bathrooms, kitchens, and outdoor areas, where there is a high risk of electrical shock. Arc fault circuit interrupters of size are another type of safety device that can help prevent fires. SIs detect arc faults, which are dangerous electrical conditions that can cause insulation to break down and ignite nearby materials. SIs are required in certain locations, such as bedrooms and living areas, where there is a high risk of fire. Surge protection is also important for protecting sensitive electronic equipment from damage due to voltage surges. Voltage surges can be caused by lightning strikes, power outages, or other electrical disturbances. Surge protective devices SPD divert excess voltage away from sensitive equipment, preventing damage and extending their lifespan. SPD are available in various forms, including whole-house surge protectors and plug-in surge protectors. Proper wiring methods are also essential for ensuring electrical safety and reliability. All wiring must be installed in accordance with the NEC and local regulations, using approved materials and techniques. Conductors must be properly insulated, supported, and protected from physical damage. Connections must be tight and secure to prevent overheating and arcing. Regular inspections and maintenance are crucial for identifying and correcting any wiring defects. Furthermore, it is important to consider the environmental conditions when planning an electrical installation. Electrical equipment and wiring must be suitable for the environment in which they are installed. For example, equipment installed in wet or damp locations must be rated for wet locations, and equipment installed in corrosive environments must be corrosion resistant. Proper selection and installation of electrical equipment can help prevent premature failure and ensure long-term reliability. The National Electrical Code provides extensive guidance on selecting and installing electrical equipment for various environmental conditions. In addition to the technical aspects of electrical installations, it is also important to consider the human factors. Electrical systems should be designed and installed in a way that minimizes the risk of human error. For example, switches and controls should be clearly labeled and easily accessible. Electrical panels should be located in well-lit areas and free from obstructions. Regular training and education can help ensure that electrical workers are aware of the potential hazards and follow safe work practices. Furthermore, it is important to involve end users in the design process to ensure that the electrical system meets their needs and is easy to use. Communication and coordination are essential for ensuring that electrical installations are completed safely and efficiently. Electrical contractors should communicate with other trades, such as plumbers and HVAC technicians, to avoid conflicts and ensure that the electrical system is properly integrated with other building systems. Regular coordination meetings can help identify potential problems early on and prevent costly delays. It is also important to communicate with the building owner or manager to keep them informed of the progress of the installation and any potential disruptions. By following these guidelines, electrical installations can be completed safely and reliably, providing years of trouble-free service. Remember to always consult with a qualified and licensed electrician for any electrical work, and to follow all applicable codes and regulations.